So, welcome to this next chapter in our little series about how to make your own spacecraft. And today I'm going to talk a little bit about what's happening in launch and to which orbit and the position relative to the ecliptic plane you're going to get. Launch is available through various launch providers who are doing this for commercial reasons or through research and government launches, of course. But part of this Google Lunar X Prize drive is, of course, to get the private launch providers to be able to take up and use the market and provide that service. So we'll come back to that in a later video on that. But right now, I just wanted to say that you get off with a rocket from the Earth. Now, where do you get to? Well, if you start looking at my little diagram here, which is the black one is the Sun, and this is the planets as they go: Mercury, Venus, Earth, Mars, Jupiter, out from the distance of the Sun. That's well known. And the plane here is called the ecliptic plane. That's where all the planets are actually lying and where they're turning. Now, they are not at the same place relative to the Sun at the same time, but they all go in circular orbit around there. Now then, the Earth-Moon system is in here, and the Moon is actually inclined around 5 degrees, and it's not the same inclination all the time to the ecliptic plane. In our case, where we would like to hit the Moon, it is of importance where the Moon is at that time. Now, when we start from a launch, and here I've drawn the little Earth here with the axis inclined as well, relative to the ecliptic plane, it's easy to understand that this one, and if we still have the Sun over here, it depends on which time of the year where the axis is inclined relative to the Sun, and therefore relative to the ecliptic plane. What's more interesting for any amateurs wanting to get into space is that if we start from a point here on the Earth globe, perhaps 20 degrees north of equator, for just to take a number. If you start at a certain given time on a given day, and if you then delay your departure by 12 hours, so you are over on the other side, the two orbits you get when you start will actually have a different inclination relative to the ecliptic plane. If your goal is to get to somewhere else than the Earth, you are therefore dependent on the start time, which is critical for where you get relative to the ecliptic plane. This means that you need to consider all your trajectory design in view of being able to maneuver afterwards in such a way that you can still get to your goal. And we will talk more about how we do that in our chapter 4 next time on the trajectory considerations. Thank you for your attention.